So still, let's see few more test cases, okay? Few more test cases we need to focus.
Sure.
So now write the test cases for mobile number. Suppose you have a mobile number field. You want to enter mobile number. So what are the test cases you can write and how many test cases you can design for the any mobile number field. If you have a mobile number field, how can we how many ways you can test it? That's what here. See, you know, mobile number will accept only 10 digits, right? That's a boundary. So, right, 1 to 10 only it accepts. But basically 10 only, maximum 10, not less than also. So if you enter the valid test case here, 10 numbers, if you enter only, it will work out. That's the only valid test case. If you enter more than 10, it should not accept. If you enter less than 10, it should not accept. If you're leaving the mobile number field blank, it should not accept. So you think a little bit more, okay? So what other negative test case you can add more here, okay? So can you tell me what other negative test case, for example, so this field accepts only numbers, right? So
What if we
numbers
try entering alphabets?
Alphabets, excellent. And then only alphabets.
Symbols, or there's usually hashtag and
right.
number
Special
sign and all. Yeah, special characters, right?
Yeah. So these are all the things you need to input while testing. So that's the testing means. So we don't know, right, which person is going to insert all these characters or only alphabets. That we need to test it. So when you enter them, it should not accept, basically. It should not accept. Only when it, it accepts only numbers that to 10. Okay. Now, so that's a test cases you can write, okay? And a boundary value analysis testing means this is only at the boundaries, that this type of testing checks the behavior of the application at the boundary conditions. So it's performed if defects exist at the boundary values or not. So boundary value testing is used for testing a different range of numbers. There is an upper and lower boundary values for each range, and testing is performed on these boundary values. So that is the boundary conditions, how you are going to test it. Suppose if testing requires a test range of numbers from 1 to 500, then boundary values testing is performed on values at 0, 1, 2, 499, 500, and 501. So these are the values you will test it. Basically, you apply that formulas, max plus 1, max minus 1, min plus 1, min minus 1. These are the three things you have to. So how you will test this? Two techniques of black box testing. One is ECP and second one, boundary value analysis. So why do you need these things? To generate more test cases. To generate more test cases, you will use this ECP and boundary value analysis testing. Next, decision table testing. So the third one is decision table testing. What is decision table testing? So first two are when you have a edit boxes, you can use boundary value analysis and equivalence class partitioning. But so if you don't have no edit boxes, then how can you test it? That is called a decision table testing. So decision table testing is very, very helpful when you have a combination of inputs, more inputs you have. Such cases, you will use a decision table testing. So like, in the Amazon website, if you go, or any e-commerce website, if you perform the search, you have a lot of combinations on the left-hand side, right? For different filters. So you can select the different filters. That's a multiple input combinations. If you want to test that multiple input combinations or different input combinations, ECP and BVA doesn't help you. That is only for edit boxes only. But if you want to use, so this multiple combination of inputs testing, you need to use a decision table testing. So how this decision table testing will help you is, it will find out the many logical errors and also business logic problems, anything is there, it will catch. So that testers can search the different combinations with this decision table testing. So why it is important is because it will find out all the issues. Decision table testing will help you to catch all those logical errors, any business logic errors. So the developer is missing any combination of inputs, anything missing. That all those things you can catch with this decision table testing. That's the main purpose of this decision table testing thing. And also, so it will so the main advantage, as I mentioned, any complex business flow can be easily converted into test scenarios and test cases using this technique. So decision table works iteratively, and simple to understand, and everyone can use this method to design more test cases. And it provides a complete coverage of the code will be covered completely with the different test cases and test scenarios. So these tables guarantee that the combination of different input conditions can be tested very clearly and completely. That's the advantage of decision table testing. Suppose if you take here, so this is the one condition, this is another condition. These are the two conditions. So decision table is a tabular representation. Basically, in our academics, you remember the true, false, false, true, 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 false, true, true, right? So like that, we used to write. You remember that the output. First two inputs, then you will get output. So that these conditions, you can generate that many conditions. So addition table is a tabular representation of inputs versus rules, cases, or test conditions. So the inputs you are giving here only, right? These two you are giving input. So that means two. Let's take an example here. The condition, so basically number of conditions, here two conditions. So how many test cases it will generate is 2 power n. 2 power n, n is here number of conditions. So that means, so now here, how many test cases you can generate for this? This form is 2 power 2. Why? What is the 2 here? Username edit box, password edit box, two conditions, two inputs. So that's why you n value you are replacing with a 2. If more conditions are there, n value you can give whatever the number of conditions are there. So the conditions state that if user provides the correct username and password, the user will be redirected to the home page. If any of the input is wrong, the error message will be displayed. Okay, so now observe this. So 4 rules, right? We are getting a 4 conditions. One is rule 1. The conditions here is the username, password. So how many rules you will get? 4 rules, because 2 to the power of 2. That's why rule 4 you are getting. First rule, false, false. That means username wrong, password wrong you are giving. Then what is the output you will get? Error message you will get. In rule 2, username correct, password wrong. Then what is the output you will get? So you will error message. Password wrong, username wrong, password correct. Then also you will get a error message. Both are correct. Then you will land in the home page. So that is the how you can check the this number of test cases. Okay. So this is the how you can test with the different rules based on these conditions. 2 to the power of n. That's a test case. How many test cases you can generate? You need to remember this formula. 2 to the power of
n.
So n value is number of conditions.
This is very reminiscent of logic gates, like an AND gate.
Sorry?
This is very reminiscent of a logic gate, like this is like an AND gate, basically.
Exactly. So by different combinations, right?
Mm-hmm.
Different combinations you are writing. So if you test with these combinations, then you are covering all the business logics.
Mm-hmm.
That's the decision table testing means. Are you clear on this decision table testing?
Yes, so far. Yeah.
Let me show you an example also.
Mm-hmm.
For example, you are searching iPhone, okay? Now what is it? These are all conditions. So brands is one condition, price is another condition. So operating system is another condition. Phone memory is another condition. Cellular technology is another condition. Weight is another condition. These are the different conditions. Okay.
Mm-hmm.
So these are the different conditions. That means 2 to the power of all these conditions. So that means so that many test cases it will generate. Okay. So you have to write all these test cases. If you want to test all this, you have to write these many inputs. These are all inputs, right? You're selecting which that's one input.
Mm-hmm.
So that's how you can write more test cases for testing the different combinations. If you want to test that, you need to use this decision table testing concept. Okay, so let's move on next one, state transition testing. See, you just see that here when you select this combination, so the number of results will vary. Here, how many are there? 204 results, right?
Mm-hmm.
Suppose if I select average 14. See now how many you got? 16 results. So that means when you change the conditions or input you are giving, the results also will change. That's output, right? This is the output.
Mm-hmm.
Number of results is the output. Based on your input, that output is changed. So that is the so this decision table testing we can discuss that. So that's how you will test. When you have multiple combinations, you need to use a decision table testing. Okay. The fourth one is state transition testing. State transition. Transition means, right? Moving, right? Moving one place to other place. So here in the web applications, moving one page to other page. One state to other state, we are moving. That is called state transition testing. So it is a type of testing based on one state machine model, wherein so it is going to change the state when you're giving an input. Based on the input, the state will change. When you give the input, you will perform the action also. When you do the action, the state will change. So that's the state transition testing you used where. So when a system can be described, so finite state machines will be there. Finite pages might be there, different pages. So system can be in a finite number of different states, and the transition from one state to another are determined by the rules of the machine. So you give the input, perform the action, then you'll get the output. So the state will change. That's a state transition testing. Just take an example of simple, this ATM one, right? So this is the one state. So when you are doing a action means card inserting. That's an action. So from there, it will ask you some input, right? Either you enter a PIN, or you select the language, or you select the account type. Something it will change. The screen will change, right? When you do some action. So that is called one state to other state. When it will change is when you perform the action, when you're giving the input to that. So that is what this, right? The state transition testing means. So obviously it will change so that state from one page to other page. And then you enter a PIN. So when you enter a PIN first time, if you give a correct PIN, it will go to access page. You will get the access to account. And after that, so when you are trying to give the PIN not okay first attempt itself, it will ask for the second attempt. Please enter so account. Then second attempt you will try. So if second attempt, if you give a correct PIN, so you will get the access to the, see, if it is changing from here to here means the page state is changing. Again, third attempt it will ask, for example, suppose second attempt also you haven't given the correct PIN. Then it will ask enter third time. If you enter third time correct PIN, you will get access to the account. Suppose you entered a wrong PIN third time also, then your card will be blocked, right? The card will be blocked. So these are the different cases we need to test it. So that is the main concept of the state transition testing. Basically in the web pages, moving from one page to other page and all the states you are continuing. That is called state transition testing. Other than that, nothing. Okay, this is a simple example one, ATM we have taken. And you can take same thing in the Amazon website, for example. You choose the one of the product. Then see, it is moving, right? From results to what I did a click action. Then it moved to this page. So the details page, you got it. So when you perform the action, see now it will change. So it will go to add to cart. Right? So this is the how you can know. It really helps you. So that is the right different. See if you go to so this one. So maybe I don't want, I can delete them, right? I can delete. So delete. to delete. See, my card is empty now. See, state is changed now. State is changed. So even in the add to cart page also, I did a action, delete action. I clicked on the delete button, the state is changed. So that is the when you perform the action, the state will change. That is called state transition testing means. So it is going to change the state when you perform the action. So like that, you can keep moving infinite states by performing different actions on the website. Okay. So
Yes.
any questions?
No, I'm good so far.
Good.
Again, this is vaguely familiar. I think we covered this in digital systems.
Right. Yeah. So next one is error guessing. So this is all based on the tester skill. So previously you tested some application. You got bugs by, so when you're giving some different input data and you got the bug there, right? You have that experience there. Now we are testing another website. Same, that experience you can use here to break the system here, to try to get the bugs here also with the different previous experience skills you can use here to get the bugs. So basically, error guess means you are guessing the new bugs in the current application based on your previous skill set, previous experience. That is called error guessing. So what do you call that? That is called error guessing. That's it. Other than that, nothing here. Okay. So that's all about black box testing techniques. What are the black box testing techniques? Equivalence class partitioning, boundary value analysis, decision table testing, state transition testing, error guessing. 5 black box testing techniques. All these are used for your effective testing purpose. You will use that. Okay. Are we clear? So we can go for the white box testing technique. So what is white box testing? So white box testing means so basically black box is completely external behavior, right? Whatever you are seeing on the top, right? So that's the
sorry.
So you're externally you are seeing on the UI, right? User interface, you can observe that whatever the actions are happening. Now, white box testing means, so the white box testing basically main focus on the internal logic or applications code. Your main focus is you should have a fair knowledge about the code, application code. You are not bothered about the UI. Black box is you will focus mainly on the UI. You won't bother about the code. But white box testing, you will mainly focus on the code. You should have fair knowledge on the code. Applications code, like Java programming language. Some programming knowledge you should have. Then only this white box testing is possible. So how you can perform this white box testing is based on the coverage of code statements, branches, paths, conditions you will use. That's how you can perform the white box testing. So So this white box testing also called structural testing or glass box testing. So we can call this different names. So glass box testing, basically what is meant by glass box is, so what is happening inside the box? The code, basically code, your how code is executing internally. That's what you will test it. That is a white box testing each. And see, example is a car mechanic should know the internal structure of the car engine to repair it, right? So car is the application under test, which is UI that is visible for you. So the user who is using that is a black box tester. The mechanic is a white box tester, right? That is the difference between black box and white box testing differences. So why do we need a white box testing? All independent paths within the module have been exercised at least once with this white box testing. That means the code, you are going to test it with your automation test cases, basically automation test cases. All logical decisions are verified on their true and false conditions. So all loops are executed at their boundaries, lowest boundary and maximum boundary. You will check so whether that is working properly or not. So the need of white box testing is, so the logical errors, so you can easily find out in the design documents and code and different functions, you can find out. That's the main purpose. So the design errors due to difference between logical flow of the program and actual implementation. A typographical errors and syntax checking you can do with this white box testing test cases. So what are the skills required to do this white box testing is, basically you should have a fair knowledge of programming language and logic implementation. You should know how to implement the logic. You should know how to implement the logic. So what are the different white box testing techniques? We have basis path testing or structure testing. Then second one, statement coverage. Third one, decision coverage. And so path coverage. So these are the different white box testing techniques. So what is basis path testing? So don't worry about, if you're not getting this white box testing part. So because this is all, automation. So all core related. So basically white box testing, this is one of the method, and control flow graph of the program to find a set of linearly independent parts of the execution. Let me show you that so that you will get a fair idea on, go to our code. The paths, let me show you the paths. See, this is the one. See, this is the one linear path. And this is the another path. Based on your condition, the path will change. And if the condition is true, it will go this path. If the condition is false, it will go this path. So these are the path. So different paths, how it is going. So if so all these conditions, different paths, you're going to check here in this path testing. So the control flow graph of program to find a set of linearly independent paths of the execution, how it is executing, that you can find out here. Okay. Statement coverage. So basically, you will write a code, right? Number of lines of code. So how many lines of code you have written, total number of lines of code in your application. And when you execute your automation test case, how many lines of code executed? So that coverage you can get number of statements exercised, that means executed, by total number of statements multiplied by 100. If you do, you will get the statement coverage. This is one of the metric. Okay, so in your code coverage, you will get all this statement coverage, how many statements are executed by automation. They will track it easily. And decision coverage or decision testing means like you have for loop, while loop, if conditions, right? So how many are covered in your automation test case? So when you execute your automation test case, the actual developer code is there, right? The developer code has to cover. So it has to execute. So whether it is executing or not, you can check in the report. You will get in the report. You don't need to worry. Manually, it is not possible. But in the report, when you run the automation test cases, you will get the report. How many lines covered, how many loops covered, how many functions executed. All this will be excellently given by the tools. There are tools that is called code coverage tools. So number of decisions covered, and also, so those, every report you will get it. That is called code coverage. So let's join back and we'll discuss on this code coverage, how it is calculated, how the report will be there, and we'll discuss it.
Okay, thank you.
Yeah. Yeah.